Добрый вечер, дорогие друзья. Меня зовут Кирилл. Ситуация с англицизмами сейчас еще больше усугубится, потому что я буду говорить по-английски. С этой презентацией выступал на запуск конференции, которая проходила в Национальной библиотеке. Поэтому надеюсь, тем, кто там был, будет все равно интересно, потому что я надеюсь, если время останется, я покажу немножко кода. Вот. К сожалению, я слегка просудился, поэтому я надеюсь, кашель не займет всю мою презентацию, я буду очень стараться. Okay, so today I'm going to tell you about the cloud-native apps REST API testing. That's the approach we use in Neotech company. Can some of you raise hands who heard about Neotech? Okay, it's good. So quite a few of you. So before I go to REST API testing, I just going to cover a bit about Neotech, who we are, and so on the right of one of the sponsors. Neotech is a software company who has offices in few countries, mainly in Estonia and Latvia. So we have nice spacious offices, so you're very welcome to visit, because actually the Devclub page says that we are desperately looking for DevOps engineers and application support guys, as well as front-end guys. So if you would like to know more, then give me a shout, or just come. You're welcome in our office and for a talk and just a cup of coffee. So what we do, we actually deliver different types of products that are mainly do stuff with the transaction processing and the payment processing. So we do this in different languages, in Java, Kotlin, now Golang on the backend, and front-end Angular, Vue.js. Then we deliver stuff that we developed using Docker images. We built using Jenkins, and we put the stuff to Kubernetes clusters. So that's why we are all about being cloud native. So just want to ask this question, because on Tapost it was a surprise that very few of visitors do cloud native apps. So can you raise hands who are familiar with what cloud native is about? Okay, better than on Tapost. For those who are not familiar, I'm just going to quickly cover this. There's plenty of different definitions, like pivotal definition here on the internet about what cloud native is. Just like to simplify this, from my perspective, cloud native is something that relies on infrastructure as a service and uses containers, Docker or others to be deployed. So that's the main thing about cloud native. So we are concentrating on developing those apps, and 85% of our apps are cloud native. 15 is still legacy. So I know this is a stereotype. I know, and probably you will see this pyramid once again, or a few times today. So I just put this test pyramid to the presentation to show the situation with our testing that was before the framework that I'm going to tell you about, right? So this is how the test pyramid is supposed to be. So 80% of unit tests, 10 integration tests, 5 and 5 acceptance and UI tests. So that's how it's supposed to be, right? So a year ago, our test pyramid was like this. So this wasn't quite frankly a pyramid. It was more like a basement. So we had unit tests and integration tests. Here I'm talking about our primary product, which is a payment processing system. And integration tests and unit tests were written really well, and our sonar showed that the coverage was great. Integration tests, this application is built, the tests are built on top of Spring Test suite. So this provides very good tools to write integration tests or different slice tests. So all types of layers were covered with those tests. So we were very proud of that. And we thought, look, why do you need acceptance tests, right? So why do you need acceptance? There's no UI in this system, right? So it's all an iceberg down the water. No UI whatsoever. So why do we need acceptance tests or UI tests? Until we ran into a disaster. So the lesser problem was contract breaking, so that if one microservice wasn't aware of the changes in another microservice, REST endpoints contract. So we deployed the new version, and it appears that it works well on developer's machine, but it doesn't work in, like, you know, of course, my machine is great. And it doesn't work on the dev environment because another version of service B is deployed, which is not aware of the signature change there. So, but I say that's a lesser problem. Worst problem was once when the deployment was broken. So integration tests were fine, but the problem was that developers made a mistake in the Gradle script, which led to the jar file being created with 0 sites. So nothing was created in the jar. So the Docker image was created, deployed, and in production system there was a disaster because everything broke down. But the integration test passed. Thanks very much. And so we needed a solution to this, right? So we needed a complex solution. We needed an acceptance test first because we needed to test from the outside. So the test should be fast enough, and we still, like an integration test, we should be able to mock or mimic the correspondent systems that are bound to the microservices. And due to the specifics of our company, which is still a small company, we have less than 40 people at the moment. Our CTO still looks after the payment processing system. There is, I think, more than 100 integrations with different payment systems all over the world, and he is looking after all of those integrations. And if the integration fails, which happens very often, every week, and this is not our fault, he needs to, like, you know, a manager, he needs nice report, business friendly. So unit test report with true is not equals to false is not good enough for him. And the solution should be lightweight enough to run the test on the developer's machine. So while we were looking for a solution, we considered looking at the solutions on REST API contract testing. So someone heard about contract testing? Okay, almost no one. So the contract testing is supposed to help you making sure that the REST contract between the consumer and the provider is working. So the idea is that consumer defines the contract, and then the tests on the consumer and the provider ensure that this works. So there are two major frameworks out there, PACT, and which I think was the first there, and as we are basically doing almost everything on Spring, then another viable option was a Spring Cloud contract. So we considered taking the contract testing approach, but there were some issues that that forced us to look better. So the main problem is that the contract approach is great if you are writing a Hello World application. That's great. But if we have integrations with 100 payment systems, we have a lot of endpoints. So if we're gonna create a contract for each of the REST endpoints, we're gonna end up with hundreds of different contracts that we need to maintain, right? The tests are generated, which is great if you want to test just a contract. But if you want to test something more than that, then generated tests is not very good. And also, if the tests are generated, you're gonna end up with a lot of copy-paste in your tests. Yeah, and if we're talking about Spring Cloud contract, then there's a lot of Java code you have to write in order to power your contract testing. Yes, so the Spring Cloud contract creates stubs for the producer, and is testing from the producer side and from the client side. And it's so nice that it's pushing the service stubs to Artifactory, and Spring has a plugin for that. So you can use it in your tests. That's great. So this is how a typical contract in Spring Cloud looks like. It's not big, but as I said, it's nice when you have a Hello World application. You can use Groovy, YAML, or other formats to create your contracts. Also, if I'm sorry for the fine script here, if you are not on Spring, for example, you have an application on Node.js, then Spring has a solution for you. Just 30 small lines of code, and you can run a Spring Cloud contract verifier container, so that you can test your Node.js application. So we needed something more smart than this, and the solution we finally came up was something combined. So the main idea that we had in mind is that if you have a REST endpoint, you can document it, for example, with Swagger. So the good thing about it is that this is not only about Java. So any language that supports documentation in Swagger, like Golang or Node.js, they can generate a spec for you. So then you can use that JSON spec to generate a client. So regardless of what we have, we can create a client for that. Then we decided to use a Cucumber scenario as a pact, right? So it's not a technical pact. So it's described in business language to generate nice reports for CTO. But we found out that this is very convenient, even for developers and QA to write. So then the things we're left to do is we need to write the test steps, which we use Cucumber for it, naturally. And we mock the endpoints we want, or the corresponding systems we want, with Wiremock. And we use a Swagger Golden Gradle plugin for generating the clients from REST endpoints. And we run tests using Testcontainers framework. Someone heard about Testcontainers? So Testcontainers is a Java library that allows you to start Docker containers in a life cycle of the JUnit test. I believe they're working on TestNG adapter as well at the moment, but at the moment it's just JUnit 4, unfortunately. And we generate the reports, nice reports, using Oliver framework. So just to mention a sample application. So if it's a school library, where we have that we use in school library to allow school children to order their books. So this system has a front end, and it allows, and there are 3 backend microservices that store the information about books and orders in database, and there's an integration with a classes system to search for the kids. So how do yes, that's a good fun. Yeah, that's right. And the best thing is that it's published together with the framework on our GitHub. So you're welcome to have more fun with that. So how do we approach the testing of such application? First, we use as this is a cloud-native application. Every microservice is a Docker image. So we put all of those microservices in a Docker Compose manifest together with the database, and this allows us to pull up the whole ecosystem anywhere in CI, on the developer's machine, no problem. And we mock the A-class system so that we don't bother our government too much when we do the tests. So the primary approach we took was that we started up the whole ecosystem manually. We got the Swagger specs from the microservices, and we saved those specs to the Git repository with the acceptance tests. Not so good, is it? The tests that are supposed to be automated are not automated. It's only half automated. And the test flow looked like we generate the REST clients, automated. We run the tests, which includes launching the ecosystem with the test containers. We launch the mocks, and we run Cucumber scenarios, and we generate the reports. So the benefits were that scenario as a contract was very convenient, and the Cucumber let us to reuse the logic. So, for example, we can use we can save the test steps for one payment system and save it in our repository as an artifact and reuse it in other tests in other application that uses the same system. So that's very convenient. And Wiremock was very useful for mocks and for trouble emulation. So, for example, it can also let you to mimic the situation when the communication was broken or some malformed bytes were sent, and see how your application reacts to that. It's easy to bring out the whole app ecosystem, and the great side also was that REST client generation approach is polyglot. So, for example, the latest application that we we work on is consisting of a few microservices. One of them is written in Java, Spring Boot, and Kotlin, and another is Golang. So both of that is fine. It's easy to test such application. But there were some problems with that, because if the test containers are not that fast, and the Docker Compose is not that fast, and when QA works on new test scenarios, he has to restart the test again and again when he adds some test steps, and every launch takes, for example, 2 minutes, right? It's too slow. So we solved that with supported different test profiles. For example, if you want development, if you're developing the test, then you can manually launch that Docker Compose, and just once, and so the test execution on a local profile is much faster. And the REST client may be stale. So the approach when we save the Swagger specs in the repository didn't pay off, because first of all it's manual, secondly it's not always reflecting the real world. So how are we going to solve this? I'm going to regenerate the spec every time your signature changes, but what if you forget? So we solved it with regenerating REST clients on the fly. So when the test starts, Gradle puts up the Docker Compose, gets the specs, and generates the clients and runs the tests. So we updated the test flow accordingly. And another thing is that we quite fast realized that Docker Compose became a god in development, because if you are excuse me, if you are working on a microservice application, in the majority of cases you are not working with a monorepo. Each of your microservice lives in its own Git repository. So how are you going to start the application in general? So our approach that was, we have just one Docker Compose, it's an acceptance test project, and we use it when we want to test something locally. So we use it for local development as well. Secondly, the same manifest is used for REST client generation by Gradle, and the same compose file is used when we run the tests. So this approach was quite convenient. So the problems that the approach still has is that there's no clean boundary what is contract and acceptance testing. So in the same project we have other acceptance test scenarios. So for example, for another product which has Vue.js UI, we also have UI tests. They run in different suite, but still it's same repository, same Cucumber, and so there's no clean boundary. Also, the downside is that Testcontainers, if you use it, they bind you to JUnit 4. So if you want to use JUnit 5, too bad for you. And another thing is that, as I said, the majority of our applications is Spring Boot based. So there's a Spring Fox library that is used in Spring to generate the Swagger spec. So the problem is that this guy is quite limited. in functionality. So if you have a sophisticated REST API, then in many cases you have to work around this. Yeah, so actually our administrators told us that there's a better alternative to Docker Compose. It's a Kubernetes plugin for Jenkins. As I said, we use Jenkins for continuous integration builds, and our old Jenkins was just ordinary Jenkins with ordinary slaves and agents. I know agents. So it was easy to run composer because the agent wasn't containerized and there wasn't problem with that Docker and Docker anti-pattern. But our modern Jenkins is like GitLab CI, so every build is stateless and every build just creates the containers it needs and then removes them. So there was a bit of a problem with making Compose to work there. So Kubernetes plugin is nice. It allows you to run the tests on Jenkins, but there are problems. So first of all, you can't really run the tests locally. So it's very nice when you can use a Docker Compose to run tests locally. You can develop locally, bring up the parts that you need. Using Kubernetes plugin, what are you going to do? Are you going to bring up the minikube with containerized Jenkins? It's quite resource heavy. Also, the downside is that in this case, if we define those microservices in Kubernetes job manifest, the test configurations are moving from Docker Compose to the pipeline. So there's a problem with these separations of concerns. So is QA going to update pipeline each time he updates his test? Well, probably not. Also, another problem is that the solution is bound to Jenkins. Yes, so just a couple of screenshots. So we have just an example of how this contract slash acceptance test looks like. So there's a Cucumber scenario, and when you write the test cases, then you can use the clients that generated right away from the Swagger specs. You can easily mock the services that you need. All of that is included in the library that we created, and it's free to use. It's published now on GitHub. And finally, when we run the tests, we we get nice audio reports. For those of you who think how fast it is, it's quite fast. So this is a question from our real life. This is a statistics page for our payment integration system. So more than 1,600 test cases were run in 7 minutes. I think it's quite fast. Also then there's a question: why do we have to? How much effort we want to devote to actually replicating ourselves when we covered everything with integration tests? How much we want to test in acceptance tests? It's really up to you. So, for example, speaking about real life and our experience with this test automation framework for payment system, we asked QA to double every test that that developers wrote in integration tests. We asked them to duplicate them in acceptance tests. We wanted to make sure that this disaster in production environment never happens. So took QA 4 months to write those test cases. So there's a lot of time and effort and money was devoted to this. But since that, we don't have any problems with such cases. So we have that covered. When I ask QA, are you happy with that? No. Everything is tested already. Okay. Yes, so I want to repeat that our framework is open source. Visit our GitHub page and you can experiment with that. And that's basically it. Any questions?
Can
Yes?
you show previous page, please?
Previous? Yeah. This?
Thank you.
Yes?
I have a couple of questions actually.
Yeah.
Okay, so about this contract test, if it's not really specific or like private to your company, can I ask like what kind of data you are asserting actually? Like, is it only just checking the type of the data or the value itself, like, or?
It depends on the project. So actually we try to cover only things that you're supposed to cover in acceptances. So happy paths, and we try to put as much as we can in integration tests because they're faster. So yeah, but in the majority of cases you have to check for the values as well, because you know, if you want to test the contract, you have to, which is a part of our approach. Then you have to check the format as well. So there's no way around that.
And also, like, what kind of stuff that you are mocking actually? Like, do you use your acceptance tests on live environment or like?
No, we use Docker Compose. So this is started on Jenkins. So Jenkins starts up Docker Compose, and then the tests are finished, and it's all forgot.
Can't you run the services locally?
Yes, sure. Sure. As I said, there are different profiles. If we have some time left, I can show you the code, but I'm not sure about that. Yeah, so absolutely, yeah.
And for like the quality assurance, like in Java, you are writing test cases, right?
Yeah.
And which library are you using for REST API testing? If it's not private?
No, it's not. It's not private. Everything is on GitHub.
Yeah.
So, it's the clients are generated with the retrofit framework. So
Retrofit.
you retrieve. It's a HTTP client. So all of that is powered. So see, when you start the test, when you write the test, if you have those Docker Compose definitions, you have this means you have REST clients already, and it's quite self-explaining what you have there, so it's easy to write. More questions? Yes, please.
Those tests are quite beautiful and so on, but everything started with a zero-size jar.
Yes.
Why don't you have a simple test which checks delta of next jar against previous one? Like if it's raised like a 10% of previous size, raise a red flag and no.
To be honest, I don't see much sense in that.
But it will be easy and fast test which jar is 0.5, stop all the deployment and get a follow-up and so on.
But what if you put some, what if you put some images there? Or
so it's question to your developers. If they say 10% growth is okay, then okay, we'll deploy it and so on. It's quite cool.
Yes, but this means we will have to put a special effort on this jar size tracking tests, and this will require some efforts, and it will solve only one problem.
But it will took for you, let's say, 2 hours of test for size of jar, and you got, let's say, 4 months of testing for QA, who creates beautiful end-to-end tests, but they are kind of useless, let's say.
The problem with this case is that the system was already huge, and that's why it took so much time to write those tests. As I showed, it was more than 1,000 tests, so that's why it took so long to write. But if you follow this approach, this covers the jar verification automatically, so we don't care about size. We care about functionality. So if the jar is 10 megs and then it became 20 megs, what's the problem?
But again, you lost time 7 minutes for tests, X minutes for deployment, and so on and so on. You will get a red flag faster.
I don't know why I disagree actually. I think it's the jar checking size. I don't know what value it brings.
0 size. Okay.
Well,
nothing
zero size, yes. 0 size, yes. But
okay.
here you can write acceptance setup check verifies the invalid deployment and the functionality. 1 shot, 2 hairs.
But you could input it inside your pipeline. It's quite easy.
Yeah, it's all about the efforts you want to spare. So if you want to put more control, then why not? Sure.
Another question, you got now almost 2K of end-to-end tests or UI tests, and you shown
the REST tests.
Those REST tests, yeah?
Yeah.
So you shown the test pyramid before, so 80% on unit tests, and how now it looks like? Still like pyramid?
It's not quite a pyramid. it's not 5%. It's more.
Okay.
But there's a special case because of too much integrations there. Yeah. Yeah, please.
Say, who's providing the acceptance test for you?
Sorry, I didn't.
Who's providing the acceptance tests for you?
Our QA guys.
So you be sure that it's matched with the client test?
No, this CTO doesn't write tests. He is consumer of the reports. Yes.
I wasn't sure about my question, but when I heard the previous one, I understood that it's okay. One of the slides with the test pyramid that looks like a basement.
Yes.
There are 2 percentages, 80% for unit tests and 20% for integration tests.
10% for integration tests.
20.
10. 80, 10, 5, 5.
For that pyramid which looks like
Before.
a basement.
First one was
Before,
80K.
before 20.
Which was
Let's get back to that.
Yeah,
This
the next one. The next one.
This?
Yeah.
Yeah.
Yeah, I was
Yeah.
scared. So do I understand correctly that you had 4 unit tests and 1 integration test? Thank you.
And a little bit more than that.
So how much unit tests do you have?
I need for frankly speaking, I need to see a report
So if
to answer that.
if 5% is 106,000, so unit test could be 100,500.
80%.
Yes. Next. Yes.
About the amount of tests and the time it took. So in the slide you wrote it took like 7 minutes and 41 seconds, if I'm correct, and
Yeah.
the tests were like 1,642. So if you divide the time by the test, you averagely get 300 milliseconds around per test.
Yes.
And do you test also like API flows, like calls you sequentially, or just the blank single?
To be honest,
statements,
this is happening sequentially
and how do you achieve this time?
by hacks. We do not restart the ecosystem before each test suite. We just use hooks to clean up the database, so it's very fast. I know this is not
But
fair.
do you use parallelization too, or?
We decided to use parallelization. In fact, we tried our approach on Testaton, so we're gonna use it in real life. I mean the Tapos Testaton in October. But we use the parallelization where the time is it's more time consuming than here. So, for example, in another project we have a lot of UI tests that are running in browser stack, and it's taking about 6 hours to run all of them. So that's where we use the parallelization because it's quite painful, and we managed to cut it down to 2 hours, but we still have to run it nightly. Yes? More? No? Okay, thanks very much.
Thank you.